Okay, I've just finished with my non-inverting op amp. It's still here. It's still built. I'll go back to how it was set up for DC. Now it's time to do it for AC. I'm sorry, not AC, inverting op amp. So the inverting op amp, my input comes across the resistor into the inverting input. The feedback resistor is still from the output to the inverting input. We use the exact same values for that. So I want you to go through this just like we did in class. Find the gain, find the output voltage. Do note that if your input's positive, your output's negative. If your input's negative, your output's positive. There's a negative sign for your gain. Calculate the voltage and currents through each resistor. Do this before you start the build. I don't care if you complete the entire non-inverting op amp first, but then you want to do the theory in this before you start your work in lab. Okay, so here's my schematic again. Here's my pinout. I mean, it's the same things we had before. Now I'm just going to show you, if I look at this, my non-inverting input goes to ground, and my input now goes across the 1 kilo ohm resistor into the non-inverting input. If I want to build this, starting with what I already have, I've already got positive voltage, I've got negative, I got a connection to ground. Now I just want to go into the inverting input, which is number 2, through the resistor. So I take this resistor and just kind of put it over here somewhere. So it's not connected to anything else. That's where my input will come in. My input comes in here. My feedback resistor I don't even have to move because it goes from the inverting input to the output. The only thing I do need to make sure of is, if you notice, the non-inverting input goes to ground. If I do not do that, this will not work. So I just need to get a little wire and go from ground to the non-inverting input. And I'm going to grab a little wire just to plug in to ground. I'll use a green wire for this because that's what I have handy, just so I can get a hold of ground when I do my measurements. Okay, now I'm going to go through my table that looks identical to my inverting, set my input, measure my output, calculate gain the same way, calculate gain in decibels the same way. I'll end up with a negative gain here. Log doesn't work for negative input, so you just put the absolute value in there and calculate it. Do not put a negative out here. Negative gain in decibels means that the output's smaller than the input. It doesn't mean anything about inverting or non-inverting. We can't actually do that in decibels. We just have to know it. All right, so first I'm going to do is go in now, set this on ground so I can measure it. Set this for DC voltage. I'll come over here, and I want to set the input voltage. And I'll set it right where it hits this resistor. And right now I got 0, which makes me wonder. Somewhere I'm having that ground thing give me issues on this. Okay, so while you get to see me debug here, make sure that this pin is grounded. That is. That's good. Touch up here just to make sure I'm connected. So for some reason down here I'm not getting voltage out right now. Just double check everything since I rebuild it. It's 15 volts. Should be close to 15 here. So I'm just going to lift this out and start double checking this. Messing around with this potentiometer is probably the most common thing to have to deal with here. So let's just see what's going on here. Yeah, you can see I'm not getting anything off of it. That tells me I probably have a disconnect somewhere in here. There we go. I just pulled them all and checked them. When you mess around with them some, it's not unusual for them to either get disconnected where it's insulation being touched down in there or something else. So just go back and check them. Hey, look at that. I'm going to call that 100 millivolts or 0.1 volts. That's where I wanted to start. So we're going to go with it. Now I'll go measure my output. And it's 0.99 volts, so almost 1 volt. And there's a negative sign. It's inverting. I'll try one more. I'll take an input here, and let's see. Let's take it up to 1 volt. I'll have the same issue when I hit the rails on the other end. Okay, I should get up here quicker. There we go. Okay, so 1.043 volts. Check my output. Ought to be negative. Had to be a fair amount bigger. And you can see it is minus 10.48 volts. So again, like what I was just saying, is it'll have a similar issue where I'll get up here and I'll get a pretty high voltage. If I look at my output, well, there's no way I can have what I calculate for gain because it's going to hit its maximum voltage and I'll be done. So record all these, do your calculations. When you're all done, you can hook up the AC. And again, my AC will go in here. Last time I didn't, on the other, I didn't actually show the capacitors. I should do that. So I'll have to run through a capacitor, go in the positive, out the negative. So you'll have to do that for your inverting. You may or may not need to do that coming off of the output. So again, that's input, that's output. I connect my function generator, my function generator to the input, ground. Connect channel 2 to the output. And if you're having problems with these, you can talk to me. And this is our first time really messing with anything interesting in AC. This, I'm less, you should get through the DC without needing much from me. Not that I won't help you, not that I don't want to check it, especially because these are so easy to burn if you get the power supply wrong. But then I should be able to look at my oscilloscope, see the input, a nice sine wave at the prescribed values, and then see the output. In this case, it's an inverting op amp, so that output ought to be 180 degrees out of phase. You should see that clearly. It should be larger because it's amplified, but out of phase. Okay, this should get you going on this, and then let me know if you have issues as you move along.